So yeah, thanks everyone for coming. You can actually see the date at the bottom of this front slide. This is something that I presented internally to the team mid last month. And the goal of this presentation is to sort of look back over the last few months of text prompting subnets 1 and 11 and sort of report a few of the lessons that we've learned and also celebrate some of the massive successes um, that we've had. It's been major 12 months for Bittensor. And so while I would be the first to say Subnet 1 is still a work in progress, I think it holds an enormous amount of promise because one thing's for sure, we have got some very committed and talented people out there mining on it. So let's get into it. So yeah, this is basically looking back the last few months. So the question which we will really be asking ourselves when we're building a subnet, whether it's Subnet 1 or any other, is why should people actually use these subnets as consumers? So that would be people that want to build applications on top of Bittensor, which I'm sure we all understand is going to be one of the key factors. I wouldn't mute that, whatever just happened. That was a very obnoxious noise. So yeah, the questions that we have to ask ourselves is, well, how do we compare to the market out there? And as everyone knows, 2023 has been a watershed moment for language models and the services they can offer. And there's some initiatives that are already building on top of Subnet 1. But critically, we have to ask, is it faster? Can we do something that's fundamentally faster? Is the intelligence higher quality? Can you do it cheaper? Or does it have other advantages? For example, the fact that it's decentralized, the fact that you can customize your experience, the fact that it's learning and adapting online. And so with all of that in mind, we should really be critical when we build this and think about how we can make it as useful as possible. And so here are some reflections about, I think at a high level, what we need to think about for Subnet 1 and for any subnet that we're going to build, anyone in the community. Of course, we all want miners to be as useful as possible to API clients. So people actually using the validator axon to query the network, miners should be maximally useful to those because ultimately that is the product. And I think as a result, what follows from that is the validation process itself should imitate user interactions as closely as possible. A lot of different terms get thrown in the context of Subnet 1, whether it's organic queries or natural queries. But the point here is humans tend to engage with language models with a very specific use case in mind, or many different use cases. And we want the validation process to mirror that as closely as possible. As a result of that, what this really means is the reward models that we want to be building should imitate the user's preferences so that we're forcing the miners to get good at what humans value. And another thing that we will see in the subsequent slides is while it's great to have an eager community that are prepared to fine-tune their models to stay competitive and network, excessive fine-tuning, unless the landscape can keep up with it, ends up reducing the network quality substantially. So here's a picture of, I think, a utopian situation for a subnet right now. What you basically have for Subnet 1 is, this is our API client, so they're actually the ones interfacing with the network. This box right here is our network where we have some validators, you can call them this layer, and some miners down here, which is this layer. And ultimately, when this whole system works smoothly, what you have is a high quality user experience. And also what you have is a robust incentive mechanism whereby miners are competing at things that we want them to actually get better at, such that just by virtue of the competition within the network and the fact that the reward landscape cannot be trivially maximized, so that there is so much hill to climb. All of the miners have to continue climbing hills and competing against each other to do so. You get a virtuous cycle where quality just goes up and up in an almost unbounded way. And of course, the outside user would benefit from that because you basically have unbounded improvement. And also because it's open source, there's no limit to how quickly it can consume and benefit from new open source solutions that are put out there. And a byproduct of this, almost a waste product of this, is synthetic data that's generated. And this is also a very notable component of any subnet. Because your validation process is intended to be as close as possible to mimicking a user's interaction with that subnet, that means if validation is tuned well, this means that you're producing high quality data as a side product. So as I already pointed out in the previous slide, the reward models are, of course, critical to defining the behavior in which you want to define across the miners. And also, fortunately, reward models, as they are automated, I mean, even humans, they are susceptible to being exploited. They have blind spots. They can be jailbroken. There's all kinds of things that can happen. And there's strategies that you can use to mitigate that, but ultimately this remains an issue. One thing that we can do to quantify the quality of a network is, and certainly something that the research community is doing a lot these days, is using correspondence, or in other words, benchmarking. So looking at, given a completion from a miner on, say, Subnet 1 compared to a GPT or a different open source model's response, how often are miner responses from our network preferred? And another way to frame this as well is, how can we ensure that our reward model is actually aligned with our preferences? And correspondence tests are also a great way to do that. And this means, given a set of, well, 1, 2, or as many as you like minor responses, does our reward model rank them in the same way that a human would, or that GPT would, or something else? And this is, of course, a critical question that you have to ask, and it's also a great way to automate and measure the quality of a network just by looking at how much it continues to mimic humans' preferences. So just to really underscore this, the validation process should be as close as possible to the intended user interaction. And then on the other side of this, when shit goes wrong, so to speak, what basically happens is you end up converging to some unwanted behavior in the network because the reward models themselves, again, are susceptible to exploitation. What happens is, basically, users can't really benefit from the network anymore. It's excessively fine-tuned, and it's just full of kind of artificial sounding language that's not useful. Also, because now they've found a local maximum in this reward landscape, there isn't that sort of beneficial virtuous cycle of competition no longer really works. And it's actually very hard to break out of it. And eventually, what you find is a lot of miners adapt the same strategies. So everyone kind of goes to the same hill. And the problem with that is now it's actually very hard for someone to start afresh and climb the full hill, if there even is another hill in that landscape which goes higher, which would mean a behavior that is more aligned with our preferences, that is competitive. And of course, the byproduct synthetic data also suffers as a result, because now it's, well, not that useful, I guess. But now for a moment, let's just pause and look at some of the metrics that we've been tracking for the last few months on Subnet 1. One thing is for certain, it is a jet engine for synthetic data creation. In terms of volume, we've created a 100 billion plus token data set in 5 months, which is a monumental achievement, entirely driven by our community in a voluntary way. Now that we know that we have the capacity to make so much data, once we can really take full control of the incentive landscape and get mine performing the way that we want them to, we're sitting in a great position with respect to having valuable data for the rest of the research community beyond Bittensor to also take advantage of. So a little bit more detail about this data set we created. This was over 22 million steps, which were basically 22 million queries. And of those 22 million plus queries, 1.3 billion completions are included in this data set. Over 100,000, actually over 120,000 hours of validation collectively across the community. And the total data is over 600 gigabytes. So it's quite incredible. And one of the keys that facilitated this data collection was using weights and biases. Again, not everyone needs to use the same solutions, but we believe that it's been a massive facilitator for us to get visibility on who's participating in the network and also what is being produced in the network. So what you see here, this is a Gantt chart where you can basically see all of the runs, pretty much all of the runs. You can see the cutoff is almost a month ago now, but many runs, and these are over 18,000 runs across, at that time, 96 different hotkeys. So these are just the validators that are submitting their data to weights and biases. And this is in about 135 days, 134 days. So we have many runs, many hours of validation, and it's all stored to be used for analysis, to be used for understanding the health of the network, and even beyond that, for understanding language models at large, really just for pure research reasons. So now I want to show some trends that we've been seeing in the network. all of the subsequent slides are just from the perspective of the foundation validator, which should be, the data should be very, very similar to all of the other validators, at least all of the large validators. It's just a sort of less cluttered plots to just do it from the point of view of us. But anything which shows counts or throughput, you have to multiply this by the number of validators. So it's a large multiplier. So first of all, looking at two things here. So this is from the middle of June until early October. What we looked at are basically the number or the rate of successful completions from the network per day. And you see that there's some notable dips in here. These typically happen when we release something new. And so people are transitioning and adapting to whatever that new release is. But what you basically see is, despite these little dips, successful response rates have just been increasing for many months since the middle of July. They've just been going up and up and up and climbing. And when we filter those, when we filter away just successful completions to ones that we actually score as being of reasonable quality, meaning we give them a non-zero reward, so we've attested to the fact that they have some value, you can also see the same trend is actually steeper right here. And it actually continues into this month if I had those extra points in there. So also in terms of the completions per day, again, this is just from the perspective of the foundation validator, but what you see is the number of unique completions per day, which is this red curve, again, steadily increasing, which means that repetition, which unfortunately is, it's not that useful either for a user or for a synthetic data set, repetition is actually decreasing. And you can see that on this plot right here, which is the average diversity of the network as measured by exact string matches between completions, if you want to be very specific about this. What you can also see, aside from just the total diversity of the network, which is blue, the diversity among completions which got a non-zero score. So once again, you can just think of the score as our network determining that a completion had some value. Then now you're looking at the green line, which, as you can see, has been basically capped at 100% diversity. So every single completion is unique to every other completion that's ever been created. And this has just been completely clipped at 100% diversity for the longest time. So that's also really remarkable. A little bit about the rewards, and then I will go into the disclaimers behind these plots secondarily. First of all, the completion rewards have been steadily increasing. And so at a high level, this basically means, regardless of whether the content of the network has been getting better and better over time, this is proof that we have a motivated pool of people that are willing to spend the time and energy to adapt and to be better and better suited to the incentive landscapes that we've been creating. And as you can see with these vertical lines, which indicate when we release new versions, especially this bold one, which was a major version release, even when we disrupt that incentive landscape and we completely shuffle the deck, they quickly adapt, and pretty much business as usual is just getting better is the only constant on the network, which I think is amazing. On this plot, so this is for all completions. This is for, once again, successful completions, so ones that we give a non-zero score. And you can see something very similar. However, what's interesting in this case, and I should mention that we have a few different colored lines. Blue is sort of the overall aggregated reward for the network as a function of time. But you can actually break that down and look at the constituent parts of that reward landscape. And we actually have a stack of multiple reward models that are intended to operate as complementary partners inside of this larger reward sandwich. And the main thing here is what miners learned once we introduced this red model called the diversity model is they can successfully increase their total reward by keeping all of this stuff basically flat and just skimming a little bit more off the top of this one. And I'm not going to go into the distinct strategies that were discovered and employed to increase this. But the point is, I think, again, this is still an impressive feat of fine-tuning and in continuous improvement with respect to the rules that we were the ones that set them. So rewards have been consistently increasing for many months. Another plot that we have right here is the length of completions. So here what you see is the tokens inside of a given completion. And what you also see, this has been steady, actually kind of stabilized between 80 and 100 tokens in a completion. What's also quite interesting to look at is the tokens per second, which is something that we certainly would like to incentivize more of. And despite this really big spike here, which came from a sudden flurry of very creative completion strategies, let's say, if I was to just remove the average, which is being dragged by a very long tail, there were some extremely long completions that we saw for a couple of weeks in September. We take that away and just looked at the red line, which is the middle of the distribution, that has also been climbing, which means that one way or another, miners have been able to produce, have been able to inference at greater and greater speeds, which leads us to believe that they're either finding more optimized strategies for doing inference at a base level, or they're pulling new models as they become available off the shelf. They're quantizing, they're implementing basically the frontier of knowledge about how to do inference with LLMs, and they're applying it to the network, which is also really great to see. One last note I'll make about this. Why doesn't this climb indefinitely as well? Well, I would say this is harder to, because we have a fixed amount of time that a miner has to give us a completion. And so just for that reason, it's very difficult to increase the number of completions in an unbounded way. In fact, this is a much better measure, the tokens per second, so then you know how many words a miner was able to produce in a 10-second window. So some summary points about this. So what we know for sure is we have a very motivated community that is highly, highly competitive. And that is evidenced by the fact that even when we release new versions of the validator, which have different landscapes of reward models, they very quickly adapt and are often in the course of days, if not even hours in some cases, they are already finding almost optimal strategies out of the gate. So it's a very successful competitive arena in that respect. And also, as I mentioned previously, there's quite a lot of evidence to show that miners are constantly fine-tuning, which means that their individual UIDs are also getting better with time. It's not just that new UIDs are entering the network that are better than the previous generation, but fixed UIDs are also showing clear evidence of improvement. So the next part of this presentation is now going to be about evaluations. So looking at how our reward model and how the incentive landscape that we created for text prompting subnets, how aligned that is with what a human, or in this case, what a close to human proxy as a measurement of intelligence would agree on. So a little bit on the design of experiment here. This is pretty bread and butter stuff in large language models. Many of you have already seen evals like this. You basically provide a prompt, and then you provide a pair of completions. In this case, this is a validation prompt and two UIDs or two responses from the network chosen at random. And then we just simply ask, in this case, GPT-3 or 3.5 to tell us which one was better. And so the reason why this is useful is because ultimately we want our reward models to mimic what we think is good. And humans are, very, very effective as judges at this, at least in the context of natural language we are. But human evaluations are slow, and they're also expensive. And so is GPT-4. So the next chapter is about trying out how GPT 3.5 and also a much smaller model, which is fine-tuned for judging basically pairs of completions, just like I'm describing here, called Panda LM 7 billion. We've been looking at how well the two of those score our reward models. So here is a little bit more. This is just an example experiment. So this was, I believe, mid-September. I just took a specific prompt. I believe this was an augment prompt that I pulled out of the data set on weights and biases. And then what I did is I ran 500 rounds, or I think maybe this plot was 100 rounds, or a match. 100 matches. So each match is a pairwise competition between two UIDs that are selected at random, given the same prompt. And then whoever wins that match gains points based on some point system that we define. And then the idea is you just play a large number of matches, and not everyone needs to play everyone else. So if you have 50 miners, that means you've got 2,450 possible pairings. That is a lot of rounds. You actually need about 10% of that, or even 5% of that, before you've had enough UIDs play each other that you can aggregate their points and you get a pretty meaningful estimate of what the relative ranking of a given player should be given the tournament. And of course, our goal here is to have this maximally correlated with what our reward model also ranks those players as. And that would give us confidence that our reward model is indeed incentivizing the behavior that we want. So The main thing to see here is this is after 500 matches, and this is the distribution of number of matches played per each UID. So for 500 matches, most UIDs were involved in 20 matches in this pairwise comparison. And so what did that look like? Well, on this particular step that I pulled out of the data set, which I've also described down here, this is the correlation. So the y-axis is the total rewards from our reward model, and the x-axis is the points that are allocated through this tournament from GPT 3.5 Turbo. So this is certainly very encouraging. I do not expect the correspondence to be perfect because I know our reward stack isn't perfect, and also GPT isn't perfect. So two humans typically agree with each other 70 to 80% of the time on tournaments like this. So that's really a measure of your realistic expectations for agreement here. So this was very, very encouraging, and we were very happy to see this, and we thought, great, we're going to just roll this out, which I'll get to in a moment. The last thing I'm going to show here is justification of how many matches you need to play in a tournament before you converge effectively. And what you see here is it actually only took around 100 matches or so before you're ballpark in the final, in sort of that you've reached your final value, where each point in this line plot right here is the correlation. So basically the goodness of agreement between the points and the rewards. And I just compute this correlation over and over again as I play more matches in the tournament. And you can see here, you could keep going all the way up to 2,500, which is when every UID has played every other, but trust me, it just converges at some point to something in the middle. And so for economic and also convenience reasons, you just choose a cutoff. 100 or 200 matches is sufficient. So now here are some trends that you can see in the correspondence between various evals that we ran in comparison to how our reward stack worked. And it's a very different story. We were very surprised to see this. The main thing you'll see is they're scattered around 0, which means that on average, our reward model is approximately 0% in agreement with what GPT and what this other model, Panda LM, say is high quality. So basically, the rankings coming from our reward model, for one reason or another, are not in strong agreement with the rankings that are coming from GPT. And I've divided this up into separate panels just because there's discrete steps that occur inside of our validation process. So I wanted to see if there were any specific correlations within those. And realistically, there's not much, I would say. So another thing we can do is do a sanity check and see how well GPT agrees with Panda LM. So we have 2 judges, and we're assuming that they are a reliable judge. So what we're going to do is look at the agreement between the 2 of those. And that also was substantially lower than we would have expected. As you can see here, the total points in a tournament from Panda LM, total points in a tournament from GPT, we get, depending on the scoring system that we use, we get correlations that hover between 0.2 and 0.3, which I would say is low to moderate. So there's a few outstanding questions here. We think that the method is very powerful for making sure that our reward landscape is correctly ranking preferences, but clearly, ranking responses. Clearly, there's more work to be done on this. And then one more detail on the way that we ran these experiments is, just a moment. Yeah, just another note here is we actually ran every match 2 times with the completion order reversed. So you could think of given UID 1, UID 2's completion, then we reverse the order, UID 2, UID 1, just to make sure any positional bias imposed is averaged away. And what you see here is, fortunately, the number of counts, 0 means player 1-1, 1 means player 2, or UID 2-1, and what you see is both judges were at least balanced. Like, this is exactly what you expect. However, what we found, they were -1 means that they called it a tie, and -2 means that they contradicted themselves. So when you reverse the order of the 2 completions, what they actually did is they voted for the other guy. So that's a sign of inconsistency. In the literature, there's 2 different ways to deal with these inconsistencies. One option is you can just discard them. And you would discard them because the judge can't make up its damn mind. The other thing you can do is you can say, well, the judge basically never calls anything a draw. So it does have a bias. It seems like it's overly confident. It likes to say someone wins, and it doesn't like to say it was a draw. So inconsistency can be a measure of it just was very low in its confidence level when it voted for one or the other. However, given either of those criteria, either classifying contradictions as draws or discarding them, actually, that's what this harsh means. What harsh means you discard anything that was a contradiction, and raw just means you keep it and call it a draw. It actually doesn't really change the numbers at all. So that actually supports the fact that contradictions are probably close to they are useful to detect things as tie breaks. And then, yeah, I guess the last thing I show here is just the frequency at which each event happened. It's just looking at the same thing and seeing if one judge or the other was more prone to any given bias. And what we found is the distributions themselves were actually pretty balanced. As you could see, they pretty regularly voted for player 1 or 2 with the same frequency. In both cases, they rarely called anything a draw. And like I said before, contradictions were quite common. So just to summarize this part, we now know from these correspondence tests that our reward model does not rank UIDs and their completions as GPT would, at least given the samples, which was a few thousand, that we did an analysis on. We also found that 2 different judges also couldn't quite agree, which is a little bit suspect to me. However, it should be mentioned that this Panda LM is a 7 billion parameter model. It was also fine-tuned on GPT data, which means it's probably it's fine-tuned on a specific style of dialogue, and it certainly has never seen anything like the stuff that comes out of Subnet 1. So I think we can probably all agree that it was out of distribution. It had never seen anything that looked like that. But we want to build this in now. This isn't necessarily going to be part of the validation process, but for our own sanity checks, we want to make sure that whenever we release reward models, part of the checklist that has to go into releasing reward models is we want to make sure that they're very aligned with human preferences, or at least a proxy for human preferences like GPT. I have one more quick chapter, and then we are pretty much at the end of this. So another thing that we can do to measure the quality of Subnet 1 versus the outside world, which, going back to the start of the presentation, is very important and very useful, so that we can attract people to develop on top of these subnets. We can run benchmarks. So here's an example of some benchmarks that we ran for the last couple of months in stealth mode. A couple of well-known benchmarks. One is called the ARC Challenge. Another one is called Truthful QA. Truthful QA in particular is well known to be a very difficult benchmark to pass. It's considered to be a bit of a gatekeeper for like the real high-end language models, the best in the world, and sort of the mediocre ones. So scores for that tend to be quite low. Whereas ARC, I would say, is a little bit more accessible to small to medium-sized models. And that's actually indicated by these dashed lines. I'm not sure if everyone can see the annotation so easily, but GPT-4 is the highest dashed line. GPT 3.5 is the second. And then we have the 70 billion parameter Llama, 13 billion parameter Llama 2. Sorry, 70 billion Llama 2, 13 billion Llama 2, and exactly the same down here. So now a little bit about these bars. What they basically show is the performance of randomly selected UIDs on these benchmarks, as well as the entire ensemble, the entire network treated as an ensemble. So like as a collective intelligence that has some sort of voting power, because these are all multiple choice questions. Then we can ask as many minors as we want and then average their responses and come up with a final score on those benchmarks as well. And so that's what we did right here. And what we found was quite interesting. As I said, ARC is a lower hanging fruit, and the network generally did pretty darn well. In fact, there were a few UIDs in the network which appeared to be operating at somewhere in excess of a 13 billion parameter Llama 2 model's expected performance, which is fantastic, which means, if the whole network was like that, we would be cooking with gas. However, what we also found was that distribution of scores was pretty broad. And in fact, many miners did a lot worse than the top few miners that we selected. Some of them almost as bad as random guessing, which down here is 25, because there are always multiple choice questions with 4 possible answers. In the case of Truthful QA, what we actually found was the UIDs did basically as good as random guessing. They did pretty poorly. And again, excuse me. part of the reason for this is that it's a really adversarially difficult data set to be benchmarked on. But another reason for this, I suspect, and many of you I'm sure suspect, is there's a lot of fine tuning in the miners. They were not expecting to be asked questions out of these data sets with such structured responses. And so that was also part of the reason why the network didn't score so well. And it's another thing that we ultimately do want to reorient the miners towards being more flexible, being able to handle more natural, more unpredictable queries. So all of these were lessons learned for us. So a few things that I'll just touch on as well from how we learn from this experience. Clearly, we need to rethink our question and answer validation process as it stands right now, which is very structured, very predictable, and as such, very susceptible to people, to miners anticipating what's coming next, how they're going to get scored on it, and then exploiting it or doing something lazy, just like looking things up. And of course, that's not what we want miners to be doing. Something else that we're looking at right now as well is we believe that our reward models are not performing in correspondence with GPT and these other judges. Part of the reason for that is those reward models were also trained on certain data sets that had certain kinds of topics and also certain types of styles of language in them. And with the network having so much artificial sounding language, either there's a lot of system messages in there, or there's template messages, or there's just outright, things that fool language models, but a human reads it and says, this is garbage. This is not useful to us at all. That means that our reward models are also being forced to operate outside of their comfort zone. So this is the idea of train versus deploy data overlap. They were trained on maybe non-adversarial data that was all very sporting and very, very aligned with the researchers in the way that they were building these reward models. But then you bring them to Bittensor and you realize this is the most adversarial environment in the world, which is great because you can forge diamonds if they can resist the pressures of this environment. But at the same time, of course, models that were never exposed to these kind of language patterns quickly fall way below their proposed levels of proficiency. A couple of the things that we are thinking about as well are the idea of, instead of trying to do everything as an absolute reward, so giving every completion a score on its own scale, we can define the scale by means of relative comparisons. This is very reminiscent of the evals that I showed earlier, where one way or another, we determine the winner in a bunch of matches, and we use that as the basis for a point system or an ELO system. And as a result of that, you end up not actually having to define an absolute meter stick that everyone is measured against. Another benefit of this is it's naturally open-ended. And in fact, if we got to a point where most miners were pretty much getting maximum rewards within our landscape every time, then that just causes the network quality to saturate. There's no push for things to get better beyond that, other than the competitive side of inter-miner competition. However, if we only have relative scoring, it's just the hill is endless. The hill is defined by your peers that you're climbing. A couple of the things that we're actually working on right now and for the remainder of the year are we have some ideas about much more robust ways of detecting exploits in a way that's not hard-coded or presumptuous, but actually adapts to the network as things come up. We also they also start getting flagged more and more often if they're being overused. And then one other thing that's actually just being released in the coming days is streaming. Streaming is something I'm personally really excited about. It means that miners can respond with their completions basically byte by byte or token by token, instead of having to send everything over the wire when it's finished. This is a safety net for miners, because presently, if they want to give a really long, detailed, and useful completion, well, they run the risk of running out of time before that completion has finished. So they get zero. So there's a massive opportunity cost or there's a massive potential downfall to trying to provide a lot of value. And of course, we don't want it to be risky to be a fair player and trying hard. So streaming allows you to submit one token at a time. And the worst case scenario is we just take as much stuff as you gave us until it timed out. And that feels a lot fairer. And I mean, one thing that's clear from this retrospective is the validation needs to be looked at very carefully. And then I believe my last slide here is what can we do to make sure that we're doing things right, and also what can other subnet owners do looking to the future. to make their subnets as successful as possible, to attract the best miners, and to attract people that want to build businesses on top of their subnets. Well, the lessons for us are we are going to continue conducting regular evaluations, including human evaluations, to make sure that the kind of correspondence test that we did earlier, those trends are a lot more promising into the future. And this is something we can track, well, daily, hourly, at any rate that we want, ultimately, just depending on the convenience and economics of doing so. Also, the benchmarking tests were really illuminating to us. We learned a lot about what the network was doing by seeing how they dealt with some unrelated task that was not part of validation. So we're going to continue benchmarking on all kinds of different benchmarks. Also, we want to study the performance of what we call base miners. You can think of these as the miners that are already part of the text prompting repo. If we were to just inject that in there, not necessarily as an active miner, but we can do this offline, and then we can do a relative study of how a 7 billion parameter Pythia model or a Llama 2 model, 13 billion, and we can compare how they would survive and thrive in the network as well. Will also give us an understanding about whether the network is getting good at the things that we value. And the last thing I'll say here is, while we're really proud of the amount of data that we produced, a formidable data set collectively, it's also something to reflect on whether we should prioritize quantity or quality. Perhaps we can instead dedicate multiple rounds of validation to really refining a result, whether it's round by round scoring, outsourced to the miners. There's a lot of ideas that we have right now, but the point is we could reduce the amount of data that eventually goes into that synthetic data set, and the upshot of that would be to be much more confident that it has been very thoroughly vetted and it's made it through many rounds of critique, which would then mean that we're producing valuable synthetic data for everyone to use. Yeah, and that's the end. I just want to thank the team that made all of this analysis possible, and that really have been the ones maintaining subnets 1 and 11 and putting out fires for the last few months, and I hope we'll continue to do so for a long time. So thanks to the Synapse team at Bittensor. Cheers, guys.
Thanks, Stefan.
Hey.
Thank you, Stefan.
Amazing.
This really was fantastic, and I think it was quite comprehensive because there have been no questions from either the Twitter audience or here. But I see that Spunyan is currently typing. While he types, I have one quick question, if you don't mind. We're onboarding a lot of developers right now. What do you think these developers who are now building their own subnets can learn from Subnet 1?
Don't underestimate the ingenuity of people that are incentivized. And by that, what I mean is, just because you came up with a cool incentive mechanism, you need to think about it in the most adversarial terms possible. And basically, I think if you want your net to produce really useful miners, you need to make your incentive mechanism as adversarially robust as possible. And that could mean you sit down and try and think of ways to hijack your own incentive mechanism, or you just let the miners do what they do best, which is get out there and find all the nooks and crannies. So, and I think what precedes that is you need some kind of visibility on the data that your network's producing. Weights and biases has been massively useful for us. By no means does everyone have to follow suit. There's lots of other ways that you can meet your needs of your subnet. But I believe you need visibility. That's the first thing that you need. And then with that data, you need to think carefully about like what constitutes good, what constitutes bad. How aligned is this with what I would have thought is good or bad? And I think natural language, we probably chose the hardest use case for ourselves, which is kind of awesome because we learned a lot of things really fast because of it. It's just really hard to measure quality of language, especially something that is kind of left intentionally as broad as possible, which is just literally conversational AI. Like I said before, even humans struggle to agree with each other about one thing being better than another when it comes to really high quality stuff. So subnet developers should really, they should be thinking about that from day one. As soon as you release your subnet, think about how you can keep on the pulse of what is being produced in your subnet, and be prepared to roll up your sleeves and to critically evaluate the data that's coming in, and be ready to also make adjustments to your incentive mechanisms to ensure it's aligned with the goals of the subnet. good question.
Yeah, that's good advice. It certainly becomes a full-time. Go ahead if you have a question. The bomb. Or not. Capricious, you've been fiercely typing, but I think people might enjoy hearing your Australian accent. If you want to just take the stage.
Sure, mate. I'll read it out. So a lot of work is being done to try to find and stop miners from cheating. However, it seems that there's a pathway for validators to cheat that's been quietly growing whilst we're all looking the other way. That is copying weights. Validators that are copying weights are taking advantage of the system in two ways. First, they're faking their way to a higher V-trust. And second, they're reducing their overhead costs by not actually running the real hardware, such as whatever A100 GPU or such that's required. This not only undermines the quality of the network, but also its reliability. It is, in every sense, cheating. A great example of this at the moment is Subnet 8, which is currently quite raw and is not working properly. There should only actually be one validator capable of posting weights at the moment, and that's TauStats. However, if you check on the SN8 TauStats listing, you'll see that there is actually currently 4 validators posting weights, which means that the other 3 are copying them. So that means that 75% of the validators on that subnet are copying their weights. What is the plan to address this?
Can I just say, I love your analysis. Caught with their pants down. That is great.
And also, this is one putting Crux on the spot here because I have tried to organize a call with various people tomorrow to discuss this, but I'm interested to hear the opinions and thoughts now as much as Capricious.
Cool. Well, Jake, do we have you on the call right now? I feel like this is something that you would be probably the first person to speak to.
I think that this is a longer conversation that we can do maybe the next TJFT with Mog. We're going to speak tomorrow on this. Let's leave that to another conversation.
I'm going to agree. I don't think anyone should be put on the spot because there's more than two contrasting arguments to this. I think it's best left and then addressed.
Yeah, exactly. I mean, it's a longer conversation. I mean, from one side, it's not an attack vector. Victor thinks so. Some people think it is. I'd like to do a further and deeper analysis on this before I really speak to it.
Okay, so we will save that for later. Spanian, do you want to wrap us up? Or if not, I can read. What kind of exploitation detection techniques or approaches do you have planned? Is this something that you see more of an issue as the subnet grows, or could it be something that may dissipate because of the complexity of quality completions? Is this something that can be automated?
Well, I don't want to give too much away. We are exploring a few different approaches to this right now, but clearly what needs to happen is it can't be something predefined and static. We're not just going to be looking for, oh, you can't say those 10 words because we've seen them too much. It needs to be something that grows with the system. So that I would say is a prerequisite for whatever system we put in place for exploitation detection. Just saying brief as well is, as I alluded to in the presentation, we are really going back to the drawing board with how we want to create the incentive mechanism and the reward landscape for Subnet 1. It will live long and prosper, but I do know that it needs some careful analysis and some major upgrades. So with that, I think that one of the primary ways that exploits creep in right now is because it's just too predictable. It's just the steps that are involved in validation on text prompting are too predictable, and that makes it really easy for miners to just catch keywords or expect certain things to come and then do things that they know will be effective when these expected prompts come through. As I mentioned in the presentation, I want I want the internal dialogue that occurs during validation to be as indistinguishable as possible from a human engagement with that subnet. And I believe with that, it's just going to be so much harder for miners to be able to sit comfortably with their cookie cutter responses or their template responses. And it's not going to be perfect. It's going to take work, and it's never done. I don't believe that we're ever going to. I think it's very hard, given that natural language is so open-ended and so hard to quantify. I don't think this is ever going to be done, but it doesn't need to be done to be useful. It just needs to be more aligned with what humans want to do with the subnet. One last note I'll make on that as well is, of course, we don't want miners to be able to selectively respond to queries either. And I think that we will be solving that problem too if they couldn't distinguish between true user API clients queries and those generated during validation. So that's a further reason to actually make the two as overlapping as possible.
Got a question for you along the same line, don't mind. Is there any plans to incentivize greater throughput? Obviously, once you start to really query the network at scale, it becomes up to the miners to throttle just how much throughput they're willing to take. There can be a point where a miner might sort of agree to take in a much larger volume of queries, and would they then be rewarded for it? Or how would that be dealt with? I'm still thinking about what happens when the network reaches inverted commas capacity, and what defines that.
Absolutely, yeah. It's a great question. I don't have in my mind right now an explicit approach to reward that, but I mean, I can speak hand-wavingly and say that's absolutely something we should look into, so that miners that are prepared, either because they have the infrastructure set up, or they just have highly optimized models that can inference quickly. Yeah, sure. If they serve more, they earn more.
But or usually also in accordance with the weight or the stake of the querying validators. Obviously, once you reach your capacity, in the ethos of the network is that those with more stake have higher priority.
Yeah, absolutely. Well, the priority queue that's built into the miners in text prompting right now already takes into account the stake of the validator and how many queries it buys it per unit of time. So that's already in there.
Okay. Thank you.
Cheers.
Okay. Well, Stefan, Const, if there's nothing else, I think we're already 22 minutes over time. So I think it would be a good time to wrap up if there are no further questions or comments.
Great.
Okay.
Cheers, guys.
Thanks, everyone.
Thanks for coming, everyone.
Thank you, guys.
Take it easy. We'll see you soon.